This video is the second part of 3.3. We're still getting information off the graphs, but this time we'll be looking at intervals of increasing and decreasing, and also the maximums and minimums. Okay, so here's a graph for us. Should look familiar. It's kind of like our square function, only moved over a little, right? We can still look at this like we did in the last video for domain. It's off the graph though, right? It doesn't look like there's anything here, but since my picture went off the edge, we assume it keeps going. And you know, if I keep looking up here, it eventually hits it. So it is there. In fact, the domain is all real numbers. It would eventually, it's just way up there, right? But that's how it is with our square function, right? The range goes from -3 to infinity, right? Because -3 is the lowest point on this graph. And we'll talk more about that in a minute, too. What we want to talk about just first, before we talk about that minimum point, is where the intervals, where this function is decreasing or increasing. Okay, and we tell that by looking at what happens to x as we go from left to right. So we're always going from left to right, and as we go, it's way up there, but we can see it when it hits here. The function is going down. As I go from left to right, the function's going down, 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 until I get right here where x is 2. So everywhere where x is from -infinity all the way to 2, that function is going down, down, down. So that means it's decreasing. So the interval where it's decreasing would be from -infinity to 2. Then, look what happens. We're still going from left to right. Now it's going up. Up, 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 right? So as we go from left to right, here, for starting at 2 and going up to infinity, this function is increasing. So we have two parts, right? Here it increases up to 2, it decreases up to 2, and then it increases after 2. And you notice I don't say anything about -3 and how it goes down to -3. We always talk about these in terms of x, not y. So we always talk about it in terms of x. So x goes up to 2 for the decreasing, and x goes from 2 up to infinity for the increasing. Okay, now this place where we switched from decreasing to increasing, you notice that that is the lowest point anywhere around here. In fact, it's the lowest point on the whole graph. If it's the lowest point on the whole graph, we call it a global minimum because it's everywhere. That's the lowest point everywhere. And I'll show you some, though, in a minute where it's not global. There might be some parts of the graph, like the graph might turn around and come down, and it might be lower. There might be places where it's lower, but not nearby, right? So if in this general area here, on either side of it, if it was decreasing then increasing at some place nearby, and that didn't matter what else it did, we would still call it a minimum. We would call it a local minimum. Okay? But in this case, we have a global minimum, right? This is the lowest point on the graph, so it is a global minimum. Now, whenever we talk about minimums, we talk about where it happens, right? So it happens at 2. That's the x value. It happens at 2. The minimum is -3. So the value of the function, that's the y value, right? That's what the minimum actually is. But it happens at 2. So you have to be careful when you're asked a question on the test. It might be a question about when do you get a minimum or when do you get a maximum. That would be the x value. Or you might say, what is the minimum or what is the maximum? Well, that would be the y value. All right, let's look at another one, a similar one, right? Upside down. It's the upside down square function. Well, here we go. Now, as I move from left to right, you can see it's increasing, right? It's increasing right up here until -3. And then after -3, it's decreasing. Okay? So the way we would write that would look like this. We would write it in interval notation, right? So increasing from -infinity to -3. You notice that I did not include -3. And I think that that is the correct way, and your book sometimes puts it as a square bracket. But really, right at -3, it's not increasing and it's not decreasing. It's actually turning. So you should not include it in either way. Some of your answers for the homework might show it with a square bracket. If so, just ignore that and put a round bracket. That would be the right way to do it. Okay? Now, this time we have a maximum because it was increasing and then decreasing, and this is the highest point on the graph. So this would be our maximum. Okay? That we would say this as a global maximum of 4, right? That means the value, the highest value on the graph is 4, but it occurs at x equals -3. So right here at x equals -3, that's where we get a maximum. The maximum is 4. Now last time we had a minimum. So what would the minimum of this one be? There isn't one. In fact, you know, if I look down here, these just keep going. They keep going and going forever. It goes to infinity. We can never actually get to a place where there's a minimum. So there is no minimum here. Seems kind of funny that there's no minimum when it actually goes all the way to -infinity. But because there's no specific place that is the lowest point, we cannot say we have a minimum. So in this case, we just have a maximum. All right, let's look at this one. This is a interesting one, right? And here's my line. So typically, unless there's something else told to you, you should assume that if the lines go off in a certain direction off the graph like this, that they just keep going in that same direction. Okay, so we can assume that it's up there and it's decreasing, 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 right? All the way to here. So decreasing to from -infinity to -2, right? And then we increase, increase, and we'll say that's about -1/2. Oh, and now we're decreasing again, decrease, 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 right? So up to +1/2. And then we're increasing again, right? So from 1/2 to infinity, we increase again. So we end up with 2 parts, right? 2 sections. So we have to write it in interval notation, and we write it with we write it with our union symbol, right? So do you see where the increasing is? Let's just look at that one first, right? So from -2 to -1/2, and then from 1/2 to infinity. That would be our increasing. Okay? Here we go. From -2 to -0.5. That would be our, see, that was this little section right here, -2 to -0.5, where it's increasing. And then, in addition to that, so it's a union, 1/2 or 0.5 to infinity. That would also be increasing. Okay, then let's look at the decreasing decreasing, it starts out decreasing, right? So negative infinity all the way up to -2, right? And then from, see, then it's increasing, and then we decrease again here from -1/2 to +1/2. Okay? So that would be another place where it's decreasing. So, you know, some functions could be very complicated, and you could have several. You could have more intervals than just 2. You can have as many as you need to have, right? It's also possible that you wouldn't have any. Let's look at one of those. Okay, you should recognize this. It's one of our library of functions. It's the reciprocal function, and let's figure out when this is increasing and decreasing. Okay, so first of all, we come from left to right and we're going, see which way we're going? Decreasing, down, 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 and then right here it doesn't exist. And then we're going down, 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 down. So, where is it increasing? Did it ever go up? Did it ever go up, 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 up? No, it didn't. It doesn't ever increase. This always decreases. So this would be the empty set. There is no interval where it increases. It doesn't increase. Now how about when it decreases? Well, it decreases everywhere except where it doesn't exist. So you can't say that it decreases at 0 because it doesn't exist at 0. So you would have to put this as -infinity to 0, but not including 0, and then 0 to infinity. That would be the interval where this decreases. All right, here is your quiz question. Okay, I'm giving you 2 questions for this section because we're only going to have 4 videos for this day, for this quiz. So the first question, and this will be like quiz question number 2, right? Give the interval where this function is decreasing. So figure out where it's decreasing and write that interval in interval notation. For the third question on the quiz, and the second one from this video, I want you to tell me where the function has a local minimum. Okay?